In chemistry, we're often dealing with reactions in solution. So we can use the tricks that we've learned in the last two videos to relate the volume of a reactant solution with the volume of a product solution, or we can figure out what volumes of two reactant solutions we need to mix in order not to waste any ingredients in the reaction. Let's suppose that we've got, say, a silver nitrate solution, which is pretty expensive, so you don't want to waste that. I'm going to show that it's dissolved in water by putting the AQ after there. And I'm reacting that with a calcium bromide solution. When I do that reaction, we'll put AQs after everything to show that they're dissolved. Well, let's predict what the products are. This was something that we did in the first worksheet in this chapter. If I want to predict the products of this reaction, I have to list the ions that are present in each reactant. And we spent a worksheet on this. And I'm listing the kinds of ions that are present. There's really two of these bromide ions present there, but I don't really care about that. I'm just listing the kinds of them. Then I'm going to predict the products by taking the positive ion on this one and going after the negative ion there, and the positive ion on this one and going after the negative ion there. So when I put silver and bromide together, they'll form AgBr. Now, I can't put an AQ after that. If I go and I look up the solubility guidelines for silver bromide, it says bromides are soluble unless they're in combination with silver, mercury, or lead, and they're silver. So what you form is a solid here. This is a precipitate. This is a solid product. And then what's my other product? Calcium has a +2 charge and nitrate has a -1. So I'm going to form this as a product. And if I go and look up the solubilities, the guidelines tell me the nitrates are soluble. So there's my unbalanced equation. Let's balance it. Now, if I have one of these things over here on this side, if I put a 1 in front of this, there's 2 nitrates on this side. So I would have to put a 2 here. And if I put a 2 there, there's 2 silvers on this side, so I would have to put a 2 here. And there should be 2 bromides on each side, and there are 2 bromines on each side. So there is a balanced equation for this reaction. So let's ask myself this. Suppose I have solutions of all these things. How many milliliters of 0.125 molar calcium bromide solution do I need to react with, let's say, 50 milliliters of 0.115 molar silver nitrate? Now, what I want to know is how many milliliters of this reactant I need to completely react with that. So what's my roadmap going to look like? Milliliters of 50 milliliters of silver nitrate solution is going to be converted into milliliters of calcium bromide solution. So this is the solution that I want, the calcium bromide, and this is the solution I've got. Now, why did I choose 50 milliliters as my starting point? Well, remember when we were doing problems that involved molarity as a conversion factor, this means moles of calcium bromide per liter of calcium bromide solution. And this means moles of silver nitrate per liter of silver nitrate solution. And if I take away the capital M and put in what it actually means here, I can see this is a fraction and this is a fraction. Now what I'm trying to get to is not a fraction, so I want to start with something that's not a fraction. So the 50 milliliters is very convenient to start with. Now, after I pick up my starting point, the first thing I notice about any of these problems is that I'm going from one substance to a different substance. And when I'm doing that, I need a mole-to-mole ratio. I need to know how to convert moles of the first thing into moles of the second thing. And this is going to be what my roadmap is going to look like. So if I look at the balanced equation that I've got up here, it gives me the mole-to-mole ratio, like we've seen in the previous two videos. There's 2 moles of silver nitrate for every 1 mole of calcium bromide. That's the conversion factor I need there. Now what do I need here, going from moles of calcium bromide to milliliters? I'm relating a volume of solution with an amount of solute. So what I really need is the molarity. And if you look up here, you've got a conversion factor that relates moles of calcium bromide to liters of calcium bromide solution. So I can write 0.125 moles of calcium bromide is 1 liter of calcium bromide solution. Now that takes me to liters, so I'm going to have another conversion factor here that's going to go from liters to milliliters that I need to put in. But I know how to do that. 1 milliliter is 10 to the minus 3 liters. Now let's look at this other side here. So we've got this side done. We have all the conversion factors that we need there. If I'm going from a volume of silver nitrate solution to moles of silver nitrate, going from a volume to an amount, I need a molarity there as well. So it's going to be 0.115 moles, I'm getting that from here, of silver nitrate in 1 liter of silver nitrate solution. And I've got liters of silver nitrate there, so I'm going to have to put in a milliliter to mole conversion here. It's very important that you don't forget the milliliter to liter conversions on the end, because you'll be off by a factor of 1,000,000 in your answer if you do that. If you put the 1,000, if you forget to do the thousands, the factors of 1,000, if you put the 1,000 on the wrong side as well, that'll make you off by a factor of 1,000,000. All right, so let's set it up. 50.0 milliliters of silver nitrate solution. Now it gets kind of tedious to write out the units, but that's how you can see how things will cancel properly. And if you don't write out the units, you don't know what goes on the top or the bottom of the next conversion factor. So it's pretty important to do that, as tedious as it is. I know I have to have milliliters of silver nitrate solution on the bottom of the next one. So here's where I'm going from milliliters to liters. Okay, I got to get rid of this, liters of silver nitrate solution. And here's where I'm using the molarity. The liters has to be on the bottom, so it's 1 and 0.115 moles of AgNO3 on top. Now, if I stop there, this would be how many moles of silver nitrate I'd have in 50 milliliters of solution. But I want to go on from there. I want to get rid of moles of AgNO3. And here is where I am at the roadmap. I want to go to moles of calcium bromide, and I'm going to use this conversion factor. There's a 2 sitting in front of the moles of silver nitrate. Okay, now I want to get rid of moles of calcium bromide. So that has to go on the bottom of the next one. And I look at where I am on my roadmap, it's the molarity, 0.125 moles of this, and 1 liter of calcium bromide solution on top. And then the last thing I need to do is turn liters of this solution into milliliters. And that's the whole thing then. Now notice when I set it out in a big long chain like this, that I can see there's some things I don't need to key in. Here, this and this will cancel, the 10 to the minus 3 on top and the 10 to the minus 3 on the bottom. So this is going to be 0.115 divided by 0.125 will be a number that's a little less than 1, and that's a half. So it's a little less than a half times this. So it'll be a little less than 25 milliliters that I should get out. Try it yourself, and I think you see you get a little less than 25 milliliters. What do you get? It should be something like 23 milliliters, I think. Give it a try.